7 design and construction features important to seismic performance. This presentation provides property and business owners with an overview of the importance of understanding seismic risk, as well as the adoption and implementation of building codes with appropriate seismic design and construction standards. An earthquake occurs when the fault line between 2 blocks of rock ruptures, causing the ground to suddenly move. The movement causes seismic waves to race rapidly outward in all directions. Several thousand earthquakes of varying sizes occur annually in the United States, although most are too small to be felt. Overall, more than 20 states within the U.S. have a moderate or high risk of experiencing damaging earthquakes. The seismicity map shows how earthquake hazards differ across the United States. Hazards are measured as the likelihood of experiencing earthquake shaking of various intensities, as denoted by the different colors. For example, the color red is used to highlight areas near major active faults capable of producing the most intense shaking. In order to prepare for and mitigate damage caused by earthquakes, it is extremely important to understand seismic risk. One of the key ways to provide protection from potential earthquake disasters is by adopting and enforcing building codes with appropriate seismic design and construction standards. The seismic requirements in U.S. model building codes are maintained and updated by the International Code Council using a nationwide consensus process. The Federal Emergency Management Agency is actively involved in this process to help ensure that building codes provide an adequate level of protection. To help accomplish this goal, the NEHRP recommended seismic provisions for new buildings and other structures, Fema Publication P750, is developed for Fema through the Building Seismic Safety Council and serves as a resource used by codes and standards organizations to create seismic-resistant design and construction requirements. The seismic provisions of the nation's building codes provide performance goals for seismic design and construction that address many characteristics important to the design of buildings and other structures to ensure adequate performance in strong earthquakes. These include stable foundations, continuous load paths, adequate stiffness and strength, building regularity, redundancy, ductility and toughness, and ruggedness. In addition to being able to support a structure's weight without excessive settlement, the foundation system must be able to resist earthquake-induced overturning forces and be capable of transferring large lateral forces between the structure and the ground. Foundation systems also must be capable of resisting earthquake-generated ground deformations without causing large movements in the supported structures. It is very important that all parts of a building or structure, including non-structural components, be tied together to provide a continuous path that will transfer the inertial forces resulting from the ground shaking to the ground. If all the components of a building or structure are not tied together in this manner, the individual pieces will move independently and can pull apart, allowing partial or total collapse to occur. Strong earthquake shaking will induce both vertical and lateral forces in a structure. The lateral forces that tend to move structures horizontally have proven to be particularly damaging. If a structure has inadequate lateral stiffness or strength, these lateral forces can produce large horizontal movements in the structure and potentially cause irreparable damage or even collapse. A structure is regular if it has an equal number of walls on all sides so that the distribution of its mass, strength, and stiffness is such that it will sway in a uniform manner when subjected to ground shaking. That is, the lateral movement in each story and on each side of the structure will be about the same. Regular structures tend to dissipate the earthquake's energy uniformly throughout the structure, resulting in a relatively light and well-distributed damage. If all of a structure's strength and resistance is concentrated in only one or a few elements, the structure will not have the necessary residual strength if these elements are seriously damaged, and it could collapse. If a structure is redundant, a relatively large number of elements participate in providing a structure's strength, and if only a few are badly damaged, the remaining elements should have adequate residual strength to prevent collapse. Ductility and toughness are structural properties that relate to the ability of a structural element to sustain damage when overloaded while continuing to carry that load without sudden and catastrophic failure. Most structural elements are designed to provide sufficient strength to support anticipated loads without failure and enough stiffness so that they will not deflect excessively under these loads. Ruggedness is a property of some mechanical and electrical equipment and other non-structural building components that permits these items to remain functional after experiencing strong shaking. A rugged piece of equipment will have adequate strength and will be composed of components that do not lose their ability to properly perform their intended functions when shaken. Although nothing can be done to stop the occurrence of earthquakes, Communities can lessen the loss of life and property through the implementation of proper design and construction techniques like those outlined in building codes and standards based on the NEHRP recommended seismic provisions. To recap, the 7 characteristics important to the design of buildings and structures to ensure that they will behave adequately in a strong earthquake are stable foundations, continuous load paths, adequate stiffness and strength, regularity, redundancy, ductility and toughness, and ruggedness. A basic explanation of seismic design can be found in the Earthquake-Resistant Design Concepts, Fema P749. For more information, please visit fema.gov/earthquake or nehrp.gov. The latest version of Fema P749 and Fema P750 can be obtained through the Fema Publications Library online or ordered by phone and email through the Fema Publications Warehouse.